Hi, my dear students. We are meeting up again with further concepts of the chapter metals and non-metals. But before we go for concept discussion, let us try to recall what you have studied in the previous part. Yes, it's the time to lit the bulb in your mind. Yes, it is the revision time. Let us go for questions. First question. Which of the following is the only liquid metal which is poor conductor of heat but a fair conductor of electricity? One main point that's mentioned in the question is only liquid metal. So answer is obvious to you, but let us see the options. First option, it is copper. Second option, calcium. Third option, mercury. And fourth option is rhodium. Among all these four options, you know that only one liquid metal, that is mercury. So mercury is the correct answer. Mercury is the correct answer. So let us go further to understand another question. Name a metal which is the best conductor of heat. Best conductor of heat. Which is the metal which is best conductor of heat? Yes, we have discussed that also in the previous part, that it is A. Can you guess? Ag. What is Ag? Ag is nothing but silver. Silver is best conductor of heat. Then, which has low melting point? We had discussed that there are two metals which melt on our palm. If we keep them on our palm, it starts melting. They are gallium and cesium. So they are two metals which has very low melting point. Gallium, Ga, and cesium, C. Yes, these are two metals which have low melting point. They melt on a palm. So now coming further, let us understand which is most ductile. Most ductile metal is a metal which of 1 gram metal can be drawn into 2 kilometer length. That is gold. Gold formula is AU. So these are the answers for the question. Let us move further for further discussion. Fine, let's go further. There are a few more questions to be answered. Which property of metals is used for making bells and strings of musical instruments like sitar and violin? Violin and sitar will use metal components which produce beautiful music or beautiful sound. Okay, pleasant sound we can tell. So, which property is used? Option: ductility, malleability, sonorousness, and conductivity. Yes, if it was only strings, then your answer would have been ductility also, because strings means it's wire. Okay, but they have mentioned to you for making bells and strings. So as bells are also mentioned, in bells it's not just ductility, main concept is sonorousness. Sonorousness is ability to produce ringing sound. That's called as sonorousness. So sonorousness is helping the metal to be used in temple bells, church bells, and even musical instruments. Let us go further. Next question, give reasons for the following. First one, metals are used to make school bells. Just in the previous question we had discussed, metals are used in making school bells because they produce a ringing sound. Next one, copper is used to make electric wires. Electric wires because copper is good conductor of electricity. So that's all about revision of previous concepts. Let us move to the concept of today's session. Fine. Let us move further. Now we are going to discuss about chemical properties of metals. Chemical properties are nothing but properties shown by metals when they react with other substances present in the atmosphere, maybe with air or with water or with acid or with non-metal. What behavior it shows when it reacts with these materials will be discussed in detail under the heading chemical properties of metals. First one is reaction of metals with oxygen. How do metals react with oxygen? Let us understand about that. Metals generally react well with oxygen. Most of the metals, okay, react with oxygen to produce metal oxides. Metal with oxygen, metal oxides. Almost all metals combine with oxygen to form metal oxides. So the general formula or general equation could be metal with oxygen to produce metal oxide. This is a general equation. Okay. Then moving further. For example, when copper is heated in air, it combines with oxygen to form copper oxide, a black oxide. Copper oxide is a black oxide. Okay, it's a black in color, black color powder. Cu plus O2 produce 2CuO, which is solid copper oxide. Okay, so this is how metal react with oxygen. We have taken copper as an example. Similarly, it is similar with other metals also. For example, we have discussed in the previous classes itself, in the first chapter of 10th standard also, that magnesium will also react with oxygen when burnt to produce magnesium. Magnesium with oxygen will produce magnesium oxide, MgO, magnesium oxide, isn't it? So here magnesium is a metal. When it combines with oxygen, it produces metal oxide. So this is about how metals react with oxygen. We'll understand other examples also. Let us move further to understand other examples. So moving further, with oxygen, metal oxides are generally basic in nature. How can we know the nature of metal oxide? If we want to know the nature of metal oxide, we need to dissolve metal oxide in water and we can test it with litmus, easier one. Magnesium oxide is that. If we dissolve magnesium oxide in water, what do we get? Yes, we'll get magnesium, M should be capital, plus, magnesium oxide plus water. Water formula? H2O. Okay. So when these two react, what do you get? Can you guess? Yes, we'll get magnesium hydroxide with the formula MgOH twice. Okay, MgOH twice, magnesium hydroxide is obtained. Magnesium hydroxide is nothing but a base. So metal oxides are generally basic in nature. We can understand out of that that magnesium oxide is basic in nature. Using litmus, we can understand that. But there is also another way to know the nature of the metal oxides. If we make metal oxides react with acid, it will produce salt and water. Anything that react with acid to produce salt and water must have which nature? Base. Because you have understood that always acid react with base to give salt and water. Salt and water is obtained when acid reacts with base. So here metal oxide, if it reacts with acid to give salt and water, so it should be of which nature? It should be of basic nature, right? Okay, so metal oxides are generally basic in nature. When you dissolve magnesium oxide in water, it forms magnesium hydroxide hydroxide, which turns red litmus blue. Red litmus, if it turns to blue, then it indicates that the particular compound or the chemical is base. Okay, if the red litmus turns to blue, then it is basic in nature. Magnesium oxide with water produce magnesium hydroxide, which we have written here itself, here also. Okay, now copper oxide. Here, when magnesium oxide is dissolved in water, magnesium hydroxide is obtained. That's one way to know using litmus. I also said there is another way by making metal oxides reacting with acid to produce salt and water, right? So here they have taken a metal oxide, copper oxide. Metal oxide is copper oxide that's taken. Okay, so here it is copper oxide is metal oxide, and they have taken this metal oxide, and this metal oxide when reacts with HCl. What is HCl here? HCl is acid here. Okay, so metal oxide when it reacts with acid, it's found that which is an acid, it forms copper chloride, a salt and water, which indicates that copper oxide is basic in nature. So here is the formula or the equation. CuO plus HCl gives CuCl2 plus H2O. Okay, so this is how we can understand the nature of metal oxide, and we can conclude that metal oxides are generally basic in nature. They produce basic oxides. Metals produce basic oxides. Let us move further. Reaction of metals with air, further continuation. What about reaction of various other metals with air? We have discussed how magnesium reacts. Magnesium on burning with air produce magnesium oxide, white ash, okay, which on dissolving with water produce magnesium hydroxide, which turns red litmus blue, right? And copper we have discussed. Copper on burning in air produce copper oxide, which is a black powder, right? That copper oxide when reacts with acid like HCl produce copper chloride, CuCl2 and water. CuCl2 copper chloride is salt. Now let us discuss how other metals reacts. Coming to sodium and potassium. Sodium and potassium reacts vigorously with air. As it reacts vigorously with air, it is stored under kerosene. It's stored under kerosene as it reacts vigorously with air, because it can even catch fire when kept exposed to environment. It can react with oxygen and produce fire, so it is stored under kerosene. So they are highly reactive metals. Sodium and potassium are highly reactive metals. The surfaces of metals such as magnesium, aluminium, and zinc, lead, etc. are covered with a thin layer of oxide. This layer of oxide is actually a protective layer. The protective oxide layer prevents the metal from further oxidation. Sometimes in some metals like magnesium, aluminium, and zinc, protective oxide layer is formed. Protective oxide layer is formed which avoid further oxidation of metal. Now coming further, magnesium burns in air to produce dazzling flame. In the first chapter, chemical reactions and equations, we have seen that magnesium burns in air to produce bright, dazzling flame. Iron does not burn in flame. Iron does not burn in flame, whereas iron fillings, if sprinkled over the flame of the burner, then it can burn vigorously. It will burn vigorously if the iron fillings are nothing but powdered iron. Powdered iron is put on the flame, okay, then it will burn vigorously. Vigorously means fast. Copper does not burn, but we have already discussed copper reacts with air to produce copper oxide. Black layer of copper oxide get formed when you burn copper. Silver and gold do not react with oxygen even at high temperature. So this is how various metals react in different way with air. Not all metals react the same way. Like sodium and potassium reacts vigorously. Okay, so we can consider that they are more reactive. Magnesium burns with a dazzling flame, less reactive than sodium and potassium. Aluminium, zinc, lead, and even magnesium to some extent gets coated with thick layer of magnesium oxide, aluminium oxide, zinc oxide, and lead oxide. That's respective oxides, which act as a protective layer of oxide. Okay, protective oxide layer get formed which avoid further oxidation. Whereas iron fillings will burn vigorously, only fillings, not the iron rod or iron nail, do not burn. And copper gets coated with black color copper oxide, whereas gold and silver do not react with air at any high temperature. So based on this understanding, we can conclude that some metals are more reactive, whereas few metals are less reactive. Now we'll understand about a concept that is amphoteric oxides. What are these amphoteric oxides? Amphoteric oxides. Let us try to split the word amphoteric oxides. Ampho means both. Okay. Amphibians, you might have heard, right? Ampho means both. So amphoteric oxides. Just before we have discussed that metal oxides are basic in nature. Whereas there are some metal oxides which shows both basic nature and acidic nature. Such oxides are called as amphoteric oxides. Metallic oxides are generally basic in nature, whereas there are some metal oxides like aluminium oxide and zinc oxide. Aluminium oxide is Al2O3. Aluminium oxide is Al2O3. Okay, and zinc oxide is ZNO. ZNO. So these two are actually amphoteric in nature. They're amphoteric in nature. That means they react both, they act both as base and acid. Basic in nature also and acidic in nature also. They react both with acids and bases to form salt and water. Let us see the example with the help of an equation. ZNO plus HCl giving ZnCl2 plus H2O. Here ZnCl2 is actually salt. ZnCl2 is salt. And water is formed. Okay, Zn oxide here is now, it's actually basic in nature. It's basic. Why? Because we have taken S acid, that is HCl is that which is acid. So basic natured ZnO reacts with HCl to produce ZnCl2, which is salt and water. Okay. Another way where ZnO is reacting with NaOH. What is NaOH? NaOH is nothing but a base. So here it's reacting with base NaOH, and it is producing Na2ZnO2. This Na2ZnO2 is called as complex salt. Okay, complex salt, which is called as sodium zincate. It's called as sodium zincate. Okay, so this ZNO is reacting with base here to produce a complex salt and water. That means here ZNO is acting as acid. So by this we can understand that ZNO, that is zinc oxide, is behaving both like acid and base, hence called as amphoteric oxide. Another example of amphoteric oxide is aluminium oxide. Can you write equations by yourself about how aluminium oxide reacts with HCl and how aluminium oxide reacts with NaOH. You should remember one thing, it produces salt and water. Water is common, salt formula you should be able to generate. Okay, now let us move further. Based on this concept of amphoteric oxide, let us try to answer a question. Okay, so the question goes like this, very easy question in fact. What is meant by amphoteric oxides? Amphoteric oxides are those metal oxides which react both with acid and base to produce salt and water. Okay, choose the amphoteric oxide from the following. Na2O. Let us understand about this Na2O. Na2O is nothing but sodium oxide. This sodium oxide is actually basic in nature. Why is it basic in nature? This is because sodium oxide reacts with, it is basic in nature because it reacts with acid like HCl to produce NaCl and H2O. Let me write the equation for you. Na2O plus HCl, okay, it should be capital, produce NaCl plus H2O. O should be capital. So here NaCl is salt and H2O is water. So Na2O produce salt and water when it reacts with acid. So Na2O should be basic in nature. Coming to ZNO. Yes, ZNO is actually amphoteric. It is amphoteric in nature. Coming to CO2. What is CO2? Carbon is not a metal. Carbon is a non-metal. It is non-metallic oxide. We'll understand shortly about the nature of non-metallic oxides. Okay, so carbon dioxide is non-metallic oxide. It is non-metallic oxide. And Al2O3 is again amphoteric in nature. It is amphoteric in nature. And H2O, here hydrogen is there. H2O, we cannot consider it as metallic oxides or non-metallic oxide. It's actually water, so it is neither acidic nor basic. It is neutral. It is neither amphoteric in nature, right? So that's all about amphoteric oxides. So we have discussed about metal oxides and its nature. Metal oxides are generally basic in nature, but two oxides, that is zinc oxide and aluminium oxides, are both acidic and basic, hence they are called as amphoteric oxides. Shall we move further? So here is one thinking activity or thinking information, food for your thought. You need to keep putting food to your thoughts also, not just to your stomach. Okay, you should fill your mind with good thoughts simultaneously as you fill your stomach with good food, good healthy food. So here goes food for your thought. Anodizing is a process of forming thick layer of aluminium. Aluminium develops thick oxide layer when exposed to air. This aluminium oxide coat makes it resistant to further corrosion. The resistance can be improved further by making oxide layer thicker. During anodizing, a clean aluminium article is made the anode and is electrolyzed with dilute sulfuric acid. The oxygen gas evolved at the anode reacts with aluminium to make thicker protective oxide layer. This oxide layer can be dyed easily to give aluminium article an attractive finish. This is one way to protect aluminium article from getting corroded. Okay, when you purchase any aluminium articles, like aeroplanes are also made up of body parts of aeroplanes is also made up of aluminium, but that should not be corroded, right? They are there. We can go for anodizing. What they'll do, they'll take aluminium rod, whichever aluminium article which has to be anodized, they'll keep it in anode. Okay, and they'll dip the solution in uh, sulfuric acid. They'll pass the electricity. When the sulfuric acid, when current is passed to sulfuric acid, it will split and will produce oxygen gas near the anode. That oxygen gas will react with the aluminium article kept as anode and produce oxide of aluminium, which gets coated over that aluminium article. Hence, this anodizing process helps to prevent corrosion to some extent. So, anodizing is a method to prevent corrosion. Anodizing is a method to prevent corrosion. So, it prevents corrosion to some extent. Okay. So, it's an easy and best method to prevent corrosion, as thick layer of aluminium oxide will avoid further oxidation of the metal. Now, there's another term that you need to understand is about alkalis. What are alkalis? Alkalis are nothing but bases which dissolve in water. For example, sodium hydroxide and potassium hydroxide both are alkali because they dissolve in water to they dissolve in water to produce alkali. Sodium hydroxide is commonly called as caustic soda. Potassium hydroxide is called as caustic potash with the formula NaOH and KOH. Now, let us discuss how the reaction with water occur. Let us watch a video, okay? Okay, dear children, can you see a website of OLabs that's funded by MITI, that is Ministry of Electronics and Information Technology. Okay, this is a website OLabs from Amrita Vishwa Vidyapeetham, okay, which help us to provide various science resources, especially electronic or virtual labs, which provide us with various simulations and animations, and will also give us theoretical information about various reactions, various chemistry and biology, even physics reactions. Okay, so we are grateful to Amrita OLabs, that is Amrita Vishwa Vidyapeetham, for providing these great resources which help us to understand better about laboratory techniques and about lab knowledge or practical knowledge in virtual method. Okay, so here we are reaction of metals with water under different temperature condition. Let us go for the simulation. Okay, Here they have various instructions are given. Let us read the instructions first. To show or hide the metals information, click on the circle button. Drag and drop the spatula into the watch glass containing sodium. Okay. Drag and drop the spatula onto the test tube A. So here spatula is there. This is spatula, and here metals are there. We need to drag the spatula to the metal and put it to the various test tubes containing cold water. Here cold water is there. Let us see spatula. Spatula is getting filled up with the metal that's been added to test tube A. Test tube A. You can see the reaction, what's happening, any change. Yeah, you can see that it start producing fire because sodium, this is sodium, reacts vigorously with cold water. Also, it reacts vigorously with cold water. Yeah. So here sodium, silvery white color, reacts vigorously with cold water. Now let us take magnesium, second metal. Spatula is getting filled up with magnesium. It's also white, silvery white. I'm putting it to test tube B. Because in test tube A already sodium is added. Observe if any reaction is taking place. No, reaction is not seen in magnesium. Now let us see with zinc. Spatula is getting filled up with zinc. I'm putting it to test tube C. No reaction again. Lead, gray color. Putting it to test tube D. No reaction again. Iron, silvery gray color, silvery gray. Putting it to test tube E. No reaction again. Aluminium, silvery white. Putting it to test tube here. No reaction again. Copper, red orange. Okay. Adding it to test tube G. So here we can conclude that sodium reacts violently with cold water. The reaction is so violent and exothermic in case of sodium that is evolved hydrogen immediately catches fire and the reaction goes like this. So here we have understood how metals reacts with cold water. So we can come to